This is a brief demonstration of the interactive figures in PreCalculus Trig. Each figure has a page with an explanation. Also, each figure has a page with an exploratory exercise. In this figure, we may move the time slider or run the animation of the Ferris wheel. The height slider can be used to estimate the height of a point on the graph. The show guidelines show the lowest point, the center point, and the highest point on the graph. We can show equation for the height of the point. This function is in terms of the sine function. Show labels indicates on the graph the amplitude and the period of the function. We can also show equation for the height of the point in terms of the cosine function. In this figure, the t-slider moves the point on the unit circle the number of radians selected as the ticks on the circle. The value of each tick on the circle can be changed to any one of the 6 indicated. We can also show the coordinates of the point as it moves around the circle. By checking the coordinate calculations box, we can see the calculations for 3 angles, pi over 3, pi over 4, and pi over 6. We see that pi over 6 and pi over 3 share related values. This figure shows the values of the sine, cosine, and tangent functions, and their reciprocal functions, cosecant, secant, and cotangent. We may also show the tangent slope segment when viewing the values of the tangent function. The tick marks on the unit circle may be chosen from one of 7 values ranging from 1 degree to 60 degrees. The functional values may be shown in exact values or approximate values to 4 decimal places. This figure shows transformations of the sine function, the cosine function, and the tangent function. The figure will also show the plot of the function. Changes in the A value changes the amplitude of the graphs for the sine and cosine. The B value is related to the period of the function. The C value is related to the horizontal shift. The D value is related to the vertical shift. The solid guideline shows the vertical change from the x-axis. The dashed guidelines reference the amplitude for the sine and cosine functions. The figure also shows the vertical asymptotes for the tangent function. This figure shows the solution for the side-side angle type of oblique triangles. For these dimensions, there are 2 triangles. By moving the swing side A slider, we can show the solution to the second triangle. For some values, there are 0 triangles or no solution. For some values, there's exactly 1 triangle. This figure shows rectangular and polar coordinates. We can click and drag the red dot on the grid. We can show the values for the point and the formulas for polar form. The coordinates can be shown in rectangular or polar form. The graph can be shown on a rectangular grid or on a polar grid. We may choose to show the negative angle and or the negative radius on the graph. This figure shows the graphs of polar form functions. One of 9 functions may be chosen by clicking on the Select Function button. The graph is constructed by moving the T slider or by running the animation. The shape of the graph may be changed by using the active sliders. One of 3 window sizes can be chosen to view different size graphs. The equation of the function may be shown. The coordinates may be shown in polar form using radians or degrees. In this figure, we may need to adjust the window setting to see all of the vectors. We see scalar multiplication with positive values and with negative values. We cannot get a resultant vector without using 2 vectors. Each of the display vectors can be dragged by the vector head. The resultant vectors r equals u plus v and w equals u minus v may be shown. Also, the polar values for each of the vectors may be shown. In this figure, we may see a hint to the curve. Also, we may rotate the grid for x of t in order to put x on the horizontal axis. The graph may be created by moving the T slider or by running the animation. We see both the x values and the y values and the graph on the xy plane. We may choose one of 6 functions for x of t and one of 6 for y of t. By running the animation, we get the graph. In this case, we are using x equals 6 cosine of t and y equals 6 sine of t. We see that we get a circle whose radius is 6.